It's George, and I'm back again. I'm here to talk about something that nobody else is discussing or even bothers looking for. It's called unfinished or incomplete meteorites, which it does happen. I'm going to show you and I'm going to explain. Now, first we have here 3 solid metal concretions. Now, if they're solid metal, you should be able to separate this outside part. Like in this one, you should be able to separate this outside part from this. But you can't, because it's metal. It's the whole concretion is solid metal. And same with this one. I call this one the avocado because it looks like an avocado. But this metal part, the metal center of the concretion, is intact with the metal outside. Okay. Now, we keep that in mind. Okay. Now, why do I say unfinished? Okay. Here we go. Okay. This thing looks like a rock. Okay? And I think everybody can agree this looks like a rock. But when you pull open the inside, this is what you get. That's all metals, minerals, silicates, everything. It's incomplete. And I'll explain why this is incomplete and what happened. And anyways, so everybody wants magnet, ugly rock, and the magnet sticks right to it. Okay? Now, if you took a picture of this, and you send it like the experts want you, send a picture. Oh, we can tell what a meteorite looks like. That's totally wrong. You cannot tell what a meteorite looks like by looking at a picture, especially if it's incomplete or unfinished. And I will get to the term, and most experts will understand this. Okay? But you look at this. Okay, yeah, it looks like a rock. Okay, you break it open. Okay, this right here is a solid iron core. And this is partially iron on the outside. This thing did not break up like it was supposed to. When coming through the mesosphere, there was a problem there, and there was a problem with the temperature. And that problem with the temperature, it causes the martensite transformation, which happens when metal cools too quickly. If it cools too fast, this is what happens. And you get incomplete meteorites. But nobody wants to look for it. Nobody wants to look for meteor showers that hit the earth neither. Okay? Because they say it's impossible. Everybody goes from this humongous rock like this. They see it come across the sky, and then everybody goes and looks for a little teeny fragment like that. Nobody ever looks for whole rocks, and nobody ever looks for bits and pieces and fragments or a meteorite debris field. And they do exist, and they are out there. And this is the stuff I'm trying to explain. Okay, it's bizarre stuff. But you look up the martensite transformation, and then you start looking up everything else I've been talking about, and start putting 2 and 2 together. But you know, people will refuse. People refuse. Okay. Now, I made a mistake, and I apologize. Okay, I apologize. I made a mistake. I thought that this whole thing was metal. Okay, I had it cut open. So, here we have the metal part. When you come around and you see the cut part, oh, well, look at that. Okay, this is an incomplete stony iron meteorite. Stony iron, okay? It's incomplete. You don't see a lot of it. Okay? The trowelite is golden brown and tannish. Okay? The white dots and the white lines in it is the calcium-rich inclusions. The shiny metal that you see on the outside is the FeNi nickel. This is what you see on a palisite. Now, which type of palisite this is, I don't know. But this is a stony iron. Okay? Whether people want to believe it or not. But I got some other bizarre stuff here. I'm not done. I got these weird looking rocks. Okay? This weird looking green rock with bumps on it. And the kind of inside that it has is weird. Okay? It's got a little bit of magnetism to it. And this is what you would expect to see if a meteorite doesn't complete. If when the meteor comes in, if it doesn't complete the process to becoming a small fragment meteorite, this is what you're going to get. Now, I had this one cut open, okay? It doesn't look pretty on the outside, but you can see here where it was burnt. Okay, this was a concretion that had a metal outside, okay? Now in here it was cut open, gray, white, and these blue dots. Now I don't know what the blue dots represent. I don't know what it is. I don't know if it's a metal. I don't know what it is. But when we take the magnet, okay, you can see that. And you can hear it. Why is it magnetic? Okay. We're going to get to even the better one, okay? This one I had cut open too, okay? This is a metal outside. But what's really bizarre about it is when you go to the inside looks like that. It just looks black and dark. It looks black and dark. Okay, so let's go. You see how hard the pull is on that magnet? Okay? Watch it again. And you can hear it. Okay. Tell me, what kind of metal is that? And this is what I'm coming across. What kind of metal is black in a solid state form? Okay? Now, here's another thing. I had this one cut open. And you look at that. Okay? You look at now, if I'm correct, that is black plessisite. And that stuff forms, it forms when the metal cools too quickly. And let's check it. Okay? I don't need to sit here and play with the magnet all day long. The magnet is sticking to this stuff. Now, why did I say this one's a stony iron? Okay? You saw the black one. Okay? Look at this one. There's no real magnetic attraction, which means that the iron nickel content in it is really low, and which is what you would expect to see if you're looking at a stony iron meteorite. anyways, I hope that this clarifies things, because my next step will be to start testing, getting one of those little x-ray guns and seeing what the composition is of these rocks. But I got a feeling, by everything that I'm finding, I got a feeling I'm going to come up right. And a lot of people are going to be out there wrong. And a lot of people are going to be out there feeling like a fool because they were sitting there poking fun of me the whole time. But you look at online, I'm the only one that's talking about this. No expert will sit here and talk about incomplete meteorites, meteorite debris fields. Nobody will talk about that stuff. And so we're supposed to believe that the mesosphere is perfect. Well, it's not perfect. If the mesosphere was perfect, you wouldn't have a 66-ton Hoba meteorite. And you wouldn't have the Willamette meteorite. Okay? But a lot of this was created by what I'm talking about. That event, the meteorite smoke, altered the temperature and the density in the atmosphere. That's why you're seeing what you're seeing. Now, I'm not forcing anybody to believe. I'm not forcing anybody to watch. But these are my findings when I'm going by what experts say. Now, if my findings are correct, then some people have taken rocks in that word magnetic, and a person says, no, it's not. It's something else. Okay, well, like I said, this doesn't tell you the weight by looking at it. It doesn't tell you the composition by looking at it. It doesn't tell you whether it's magnetic or not by looking at it. Okay, if I set this picture in, a person's going to say it's a rock. And that's the bottom line. They think these things are rocks. They're not. They're incomplete meteorites. They didn't finish all the way. They're sort of like the 1833 meteor shower, whether people want to believe it or not. These things came in and they boiled in the mesosphere like eggs. From the inside outward. But, like I said, people are going to want to believe what they want to believe, and they want to believe the old way that everybody's been taught. But the stuff that I'm showing here makes me think differently. Makes me think that everybody is on the wrong track. And there's a lot more out there. And if I'm true, something like this would hold a lot more information, and people would understand the universe and how everything was created a lot more, because all of this stuff didn't burn up. And anyways, that's going to do it. That's going to do it for now.